Okay, you've got a thermometer, and when the temperature is -10 degrees, the mercury inside goes up to a height of 2 centimeters. When it goes up to 0 degrees, it goes up to 3 centimeters total. Okay. And we have to assume down here that it's a -30 at the base there. Then when it goes up to 40 degrees, (7 centimeters). Okay, so if X is the temperature and F of X is the height of the mercury. Okay, you've got an interesting setup here. You've got a heat lamp, okay, bearing down on a candle. Maybe it's an experiment or a test by the candle company to test the melting of the wax. And what they do is they turn this heat lamp on for 1 hour and see what's the height of the candle after 1 hour. So the original height of the candle is 12 inches. And so they turn it on for 1 hour at a heat of 100 degrees Fahrenheit. Okay, 100 degrees Fahrenheit. So after that 1 hour at 100 degrees Fahrenheit, that candle burns down to a height of 10 inches. Okay, so that's the idea here. We're talking about the 100-degree heat lamp for an hour makes the candle go to a height of 10 inches after the 1 hour. Okay. Now they do another test, and instead of 100 degrees, they do 120 degrees Fahrenheit for 1 hour. Okay. 120 degrees Fahrenheit. And that burns it more in that hour. So again, they replace it with another 12-inch candle, and then they burn that candle at 120 degrees for 1 hour, and that burns it down to 9 inches. Okay. Now they try it again. Again, they replace it with another 12-inch candle, and now they're going to try 160 degrees Fahrenheit. Okay, so 160, and that actually burns it down to 7 inches. Okay, 7 inches. Sorry, I should probably put the other one. That's 9. And 160 degree lamp for an hour takes the 12-inch candle down to 7. And lastly, they did 200 degrees heat lamp for an hour, and that burned the candle down to 5. So again, if X is the temperature of the heat lamp and F of X is the height of the candle, height of the 12-inch candle after 1 hour. Okay, so you've got a jar here, and you're trying to open the jar, right? But it's stuck. And it's stuck because it's too tight, right? So one trick is to heat that top up, and by doing that, it expands. Okay, so currently it's at 60 degrees and it's too tight, and that has a width here. This is the top view of this. Has a width here of 9 centimeters. Okay, that's the width at 60 degrees Fahrenheit. Okay, now you're gonna run that under some warm water to get it up to 80. Okay, 80 degrees, and that widens it a little bit. Okay, so that takes it out just a tiny bit. Okay, to 9.05 centimeters. Okay, so that's at 80 degrees. Now it's still too tight, so you're going to go up to 90 degrees. You're going to increase the water. Okay, you're going to go to 90, and that's going to increase it a little bit more to 9.06 centimeters. It's still too tight, So you're going to go for it. You're going to take it up to 110 degrees, which is hot. You're going to have to put a glove on for this. And that 110 degrees makes it go up to 9.065 centimeters, and it comes off. So if X is the temperature and f of X is the width of the cap. Okay, what we've got here is something called a potato gun, okay? And it launches potatoes through an explosive reaction. So what you do is you get a plastic pipe. It's about this big. When you look at a person, you can kind of put it on your shoulder. It's, about that wide. Something you can make at home, only under adult supervision. Got that? Here's how it works, okay? So it's a long tube that's closed off on this end, so there's a cap. And what you do is you jam a potato in the front of it that's kind of stuck. So you got to make it so potatoes kind of get jammed in there. Then you fill the inside with something that's flammable, like a hairspray or something, nothing serious. And then you have a little thing on the end here that when you turn it, it creates a little spark in here. That'll kind of set this stuff on fire, and it just causes like a little explosion. Nothing major or anything, and it shoots that potato out because this gas wants to expand. So in this situation, we're looking at how hot this gets. When this gets lit on fire, right, it causes kind of like a mini explosion in there, and that heats up, shooting the potato out. So, let's say we get that to heat up to 210 degrees, and that launches our potato 60 feet, okay? Okay, so maybe we put a little bit more in there the second time, and that gets us up to a temperature of 230 degrees. And that launches the potato to 70 feet. Okay, let's try it again. 270 degrees, so we really put more in there to heat it up. So that's 270 degrees. And that launches the potato 90 feet. Okay, 90. And last but not least, let's take it all the way up to 300 degrees. And that takes us to 105 feet. So if X is the temperature of the explosion, and f of X is the distance that we launch the potato. Okay, we got a hair dryer here that blows hot air onto the hair. Now it has 4 settings for heat here, okay? So we're gonna let X equal the temperature of air that comes out of the hair dryer. And f of X is going to be the distance at which the person feels comfortable holding it away from the head, okay? So the lowest setting is a temperature of 110 degrees. And at that temperature, the person is comfortable holding it 4 inches away from the head. All right. Now, the second setting takes it all the way up to 125 degrees. And at that setting, the person wants to move it back an inch to 5 inches. Setting 3 goes all the way up to 135, and that is going to get the person to hold it back 5.5 inches. And last setting is all the way up to 150, and that the person doesn't feel comfortable unless it's a full 7 inches away. So X is the temperature coming out of the blow dryer, and f of X is the distance away from the head. Okay, in this case, people wear more clothing usually when it gets colder to keep warm. So in this case, we're going to let X equal the temperature outside, and f of X equal the thickness of all of the layers of clothing you have on. So that's what we've got here. So when it's 80 degrees outside, the thickness, there's just one thin t-shirt on, and that is going to be a thickness of 1 millimeter. Okay. Now, when it drops down to 60 degrees, somebody's going to put another layer on, maybe a second shirt, okay? Maybe even a little bit of a thicker shirt. So at 60 degrees, you add kind of another little layer here, and that's going to take it to 2.5 millimeters. Okay. If it drops down to 40 degrees, 40 degrees, you're probably going to throw another sweater on, and that's going to take it to 4 millimeters. And if you go down to 20 degrees, probably add another layer underneath, and that's going to take it all the way to 5.5 millimeters. So again, if X is the temperature outside and f of x is the thickness of your clothes. Okay, so we've got a toaster here, and there's a little secret about how a toaster works. We all know that when the toast heats up to a certain amount, the toast pops up. Now, how does the toaster know when to pop it up? Well, here's how. Inside the toaster, there are two little pieces of metal that connect in an electric circuit. So electrons in the electricity is trying to pass from here through here, but these are separated. Now, when these are metal little pieces. When the metal pieces heat up, metal pieces expand, and when they expand, they come closer together. And when they heat up to a certain amount, they touch. And when they touch, the electrons go through, and that releases the toast. So that's what this is about. Okay, so X is going to be equal to the temperature of these rods as they heat up, and f of x is going to be equal to that gap, the size of that gap. So that's f of x. And again, x is the temperature of these rods. Okay, so let's say x gets up to a temperature of 90 degrees Fahrenheit. Well, this gap right here is going to be 0.85 millimeters. All right. Now, when it heats up to 120 degrees, that gap has reduced to 0.65 millimeters. Okay. Now, this gets up to 140. That gap goes down to 0.4 millimeters. At 180, that gap goes to 0.1 millimeters. So again, X is the temperature, and f of x is the gap. Okay, so in this example, we've got a hot air balloon. Okay, the hot air balloon works by heating up the gas inside this balloon, and when that happens, the balloon either rises or falls depending on the temperature of the air on the inside. So X is going to be the temperature inside here, and f of x is going to be the height off the ground. Okay. So let's say the temperature inside is 110 degrees, and at that temperature, the balloon is at a 120-foot height. Okay. If we increase, so that's 120 feet. If we increase the temperature to 112, so we turn the flame on a little bit more, that actually increases the height, okay, to 130 feet. Oops, they're decreasing. All right. If we increase it to 114, again, a little bit more flame, we actually increase the height to 140. And finally, if we go to 116, so a little bit more flame, we increase the height to 150. temperature, f of x is the height. Okay, in this case, we've got a heater that's going to be changing its temperature. And human beings like to be at 72 degrees. That's an ideal temperature for them. That's what they like. So the point here is we're going to be varying the temperature here. So x is going to be the temp of this. And f of x is going to be how far this person needs to stand away from the heater to feel 72 degrees. Okay? If the person's right up next to it, the person will feel just as whatever how hot it is, but further away it gets cooler. So when this is 90 degrees, so it's pumping out a 90-degree air, this person needs to stand 4 feet away, and then they feel 72. If we increase this to 100 degrees, that person needs to stand further back. In fact, needs to stand at a distance of 4.8 feet. Okay. If you increase this to 120 degrees, the person needs to move back even more to 6.8 feet. And finally, if you increase this to 150 degrees, they need to move back all the way to a distance of 8.2 feet. So again, if x is the temperature here and f of x is the distance the person needs to stand. Okay, in this example, we're going to see how far this person can run, long distance runner, depending on how hot it is outside. So on a 50-degree day, this runner can run 13 miles. Okay? If you increase that temperature up to 70 degrees, the person can run 11 miles. Okay? If you increase that up to 80 degrees, getting even hotter, the person can run 10 miles. And if you increase it up to 100 degrees, that person can only run 8 miles. If x is the temperature and f of x is the distance the person can run.